Hey there, welcome to my NFL project. My name's Orion, and I'm happy to show you what I've built. I'm smiling because I've put a lot of days of work into this, and I'm really excited. It not only did I finally get it working, but the results are fascinating. I kind of actually can't wait to show you what I've been up to. Before I say anything else on my project, I do want to acknowledge my co-author, wherever he is over here. Come on, you. This little man Moki has stayed right by my side for the last many days and late nights, and he's been just right there with me, rooting me on the whole time. He is genuinely worthy of whatever co-authorship he can get. Okay, so I originally was calling my project the NFL Project. Off the record, I've been more recently calling it the NFL Fortune Telling Project. At its core, my little household, mostly I love the Olympics. I find them fascinating, and it's so nice occasionally seeing the world do something nice with each other internationally instead of just bombing one another. I love the Olympics. I find them really inspirational. But I follow one other sport. I do kind of like football. Hey. And in my house, we all moved here to Denver, and so one fun thing about that is we all root for very different teams. There's always a lot of debate and a lot of nonsense. One of the questions that we end up asking is we talk about the future. And I've been watching football a little longer than some of the people in my house, and empires come and go. Players are amazing, and then 3 years later they're not, and they get injured, and sometimes they come back after injuries. And so one of the core questions in the house is about this man. Everybody debates, will this guy, Josh Allen, he's the quarterback for my friend Luca's team, will Josh Allen play well for many years to come, or is he kind of getting up there in age and he's going to tap out soon and that'll be it? And everybody's got, speculations, conjectures, theories. They've got all their different things that but we have no data. And welcome to data mining class. So I decided it would be fun to try to see if I could come up with some way of taking all the historical NFL football data and trying to come up with some actual answers to will this guy be around for a while. So the two main sites that I had to work from were, and there were a number of other options, but they just weren't as reliable, they weren't as professional sites. I went with two of the big guys out there. I went with NFL.com and I went with Football DB, Football Database. So let me show you what you got across these two websites. This is the main primary one. You've got all your nice info. It's a lush website. This is the really professional, best one. It does only have info back to 1970, first off. It also doesn't have any info on playoffs. Comparatively, this one over here, you got regular season and postseason, but most importantly, you've got all the database back to 1940, which is kind of awesome. So, downsides of this site is that you've only got the list of the top players. That's it. You've got like the worst listed player played 11 games and had, I don't know, 1,000+ yards of passing. This one, if you click the next page, it has more and more and more and more info. It's just extensive. So each of the two websites has their perks, and we were going to just, like we so often talked about in this data mining class, we're going to weave together these two data streams and get some kind of useful, cohesive whole. Step one, what did I have to do in this project? The big first problem was getting all this info off these websites. So I'm pretty qualified in Python to take a nice little website like this and strip it of its data. And, you go into the HTML code, inspect, come on. No, that's not quite what I meant. Forgive me, view page source. Easy enough. And you just scroll down here, all the data's where you want it, and you just go get it. This other website poses a completely different novel problem that I'd never faced anything like, which is that this first page, we're going to go to 2024 for a moment. It should start with Joe Burrow at the top. This page, when you click the next button, while you'll see it propagate a new HTML URL up here, it's not actually going to a new page. There's a hidden database behind this website that I don't have access to that has all the info we need. And every time you click the next button, this is an interactive chart that is like spooling down to show you the next players on it. And this is very hard to automate a data scraper for. It took me weeks to figure out. And most notably, I had to really deep dive into something called Selenium. I had to really learn my way all around Selenium. And this scraper right here, I'm really proud of. It was really hard to make and just a journey trying to get it to work. The core problems is not only does it have to be able to click the next button, sometimes there's pop-up ads on this page that you additionally have to recognize that you're stuck in, click out of it, and then continue going. And if you hard hit this website with too much bot activity, you get shut out. So you also have to make sure it's slow enough that it thinks you're human. It was a whole journey. It really was. And at the end of which, gosh, I was really proud just when I made it this far. I have a folder here called Original Data Before Any Cleaning. And you'll see the kind of stuff I've got. For NFL passing, we've got all the data from the 70s all the way through. I'm scrolling through year by year, as you can see here. We got all the stuff on Terry Bradshaw, John Elway, all the famous guys you've ever heard of. Brett Favre now in the 90s and thousands. One sec, letting my cat out. You get out here. Get out here. Come on. All right, so when I flip over to the other website's sort of data stream, you'll see that info from the 40s is much more sparse. We have a lot of n/a values. You got a lot of messy stuff. Some seasons you just have way less info on than others. And the two don't even have the same stats listed, so it's very complicated weaving these two together. Plus, we had a strange problem that I really had to wrestle with on this, is note this is 1992. I want you to watch these two columns here. 1992, 1991, 1990? A lot of the data from the year 1990 is corrupted for reasons I can't fathom. It's inexplicably a ton of zeros, and then a few random players still seem to have their unadulterated stats. Very strange. So I had to not only clean up and weave these two data streams together, but I also had to find a way of filling in and extrapolating data for the year 1990. Very strange. Lots and lots and lots of work later from there. I won't bore you with the details. Tools used, I ended up using a lot of Selenium, Chrome Drive Manager to do the scraping. Once I had the data, extensive work in, of course, the usual suspects, Pandas, NumPy, Matplotlib, just endless, endless work. Big choices along the way. Let me see if I can get photo booth up and running again. Hi. So, big choices along the way. I chose to get rid of postseason data because if two players played just about as well as each other, and then one of them made it to the playoffs and played 5 more games and the other guy got to go home for the season, it seemed unfair to so reward the player whose team around them was better. I thought about it long and hard. I thought a lot, and I just decided we're just going to let go of the postseason. Even though if you're evaluating how good a player is, how they did in the postseason really does matter, I decided to just let it go for this project. Okay, extensive cleaning later, and gosh, I had everything from those decision tree branching structure type things that we learned covered in class. I had so many different choices to make. How to extrapolate the data from 1990, all kinds of interesting things in order to best piece together the most useful data cube I could. And that's what you'll find here. Working area data cubes, and you've got this big, chonky, here's just the quarterback one, for instance, and weeks of work. And you've got all the data in the massive data cube that you need. Sorted by player, by year. I had to fill in the gap years, well, sometimes players were gone for a while. Gosh, huge complexity. Sometimes multiple players have the same name. More went into this than I'd ever want to bore you with. But I got it running, and here it is. Gosh, the whole data cube, all these players, all their info. We're talking guys from all the way back in the 40s, mixed in with people more recently. It's all here. And I truly had to take so many of the things that we've learned in class that were just theoretical and apply them. It was fascinating. We're talking originally taking the data, dumping it into the correct column. I then normalized all the columns. Let me try to summarize the flavor of the kind of decisions I had to make without getting you super... I'm probably already babbling too much. For any one given column, part of me thought about taking a particular year. I'm going to scroll back to... Give me just 1 second, sorry. Previous drafts. Original data. So here we are. We're going to look at NFL passing for a particular year. Let's say some kind of recent year. It would have been very easy to simply line all the players up and give them a rating based on each other in terms of some kind of percentile. This is a nice way of comparing because players throw the ball more in 2024 than they did in 1940. The problem is on the bottom are a whole bunch of little players who came in through one pass, maybe didn't even complete it, and then went away. And it seems very unfair that if one season twice as many people threw a football, that everybody's rating goes down. So I ended up normalizing around. I decided to go with the seventh best player in the league every year. We'll take their stats and normalize according to it. However, some seasons more players played in the NFL, so I actually normalized based on the number of teams was how I normalized it. So that's the first major thing that I did. I filled in the extrapolated data from 1990 by looking across the whole database and coming up with any player whose stats were as close as possible, sum of squared differences, more technically, to fill in these spots. Anyhow, gosh, whole long crazy thing. Skip over the whole thing. I'm just really proud I finally got it to work. It was a thing, a real life journey, and I have my data cube, whole thing, all up and running. Last teeny technical note: it seemed a little unfair when you're comparing players to each other to so judge AJ Feely for the fact that he didn't play that one year. Maybe he was injured. And so I decided instead to blend and sort of find a moving average of how the players did year after year after year. So for instance, if this is the original data cube, while this does show up in my project, a lot of what I ended up using is this blended version. So for instance, in the year 2003, you'll find that this number here is these three numbers added and divided by 3. You've got the average of these 3 makes up this number here. It just seemed a little more fair. Okay, let me show you what this program does. Tons and tons of work later, data cleaning. I ended up, let's say that you've got a player, and you've got in the current list. Let's say we take, I don't know, Cooper Rush, and you want to know about his info. For the longest time, I was thinking about, do I use k-means clustering was my first thought on the matter. I thought about some sort of supervised classification. I ended up actually doing something I don't think we entirely covered in class. I came up with, it's simple enough. I just found in all of the historical info, I found the 30 players whose stats most closely lined up with the given player. And the very last thing I'll say on this, and forgive me if I'm babbling, I came up with 3 different ways to find the closest players. One of the ways is by comparing their raw statistics, comparing their blended statistics, so we'll go in here instead. AJ Feely, who's the player closest to him? I found a way of comparing them by their raw statistics, all these entries. I then found a way of normalizing and coming up with a total value, equating approximately how good they are as a raw score. So this was another way that we're going to compare quarterbacks to each other. And then finally, their percentile of how good they were that year versus all the other players. So those are the 3 different ways that I'm trying to predict future quarterback success. And forgive me if all that was boring. Let me now show you what my program does. You go in. Before I show you anything about using this to predict future players, let's split a historical player's career in half and take a look at how well a job it does at predicting the rest of their career. Sometimes it's a good prediction, sometimes it's bad. Wish me luck here. Let's go for a quarterback. Let's go for a historical player. I'm going to select one. Sure, why not? I got a soft spot in my heart for Mr. Kurt Warner. Let's see how his career went. Looks like he played for 12 years. How much of that career are we going to take as our modeling data? Let's say we take the first, 5 years of his career. And here's what we got. This is what my machine does. This first printout is the stats version. So this is one of the 3 machines that I built. Here's his actual career up to the point that we decided to start predicting. All the blue dots are the 30 closest other players, the players whose statistics are as close as we could get them. And then here's the actual rest of his career. But again, our little predictive model did not know of that. All it had was this half here. Here's where the predictions start. And so you'll look, it looks at the future trajectory of the statistics for all the 30 closest players. And originally I had it doing a mean of those, but outliers were way too heavy. And the trouble is that some players retire earlier, and so all of the statistical predictions just were bad. They were all low. So I decided to use mode instead. So it's binning all the data points, and then looking at which bin is the most filled. And this purple highlight is its prediction. And you can tell it's really not that bad. I'm proud, sure. So that's the stats version. Here's the one that's based on the How Good Raw score. It looks like it came up with a very similar prediction. And then the percentiles one is actually slightly weaker than the other two, and it predicted a little optimistically for his career before he retires. Let me show you two more. We're going to take a random defensive player this time. Another historical player. I'm going to click R for random. It spits out Phil Hoskin. So he only played 3 years. So this time we're trying to see, does our model predict that his career ended when it did? Hey, look at that. He in fact retired after this year. And look at that. Our model predicts that he'd be down here in retirement. This one said he played 1 more year and then retired. And this one said he played 1 more year and retired. So once again, this is... I've seen it do real bad predictions too sometimes. I'm getting lucky here. Last one, let's do, how about a wide receiver, historical, random. Let's get somebody who played for a little while. Historical, let's choose, how about Wayne Chrebet? I always liked him. I was a kid back then. Wayne Chrebet, this guy's awesome. So let's say we look at the first, I don't know, how about 5 years of his career? And once again, so this is the data we put in, and it spits out just literally spot on. I'm getting lucky here. It did predict that he would retire a little before he did, but still, predictions not, ooh, that's a little worse. And best one yet, it predicted very close to the actual results. So, all put together, let's finally answer the question, all the way back to where we started. How much longer will Josh Allen play well for? Let's take a look. So if that's my machine, on a good day, let's take a look at quarterback, current player for once. We're going to select a player, and this whole project was about answering the question of how well will this man right here play. And the same pretty reliable model that you saw earlier predicts the following. It says he's going to play a little bit worse than he has been, but still fairly excellent for about 3, maybe 4 more seasons and then retire. The next model says he'll play great for about 5 more years and retire. And then this one says he's going to knock it out of the park for 5 years and retire right at the end, maybe finally winning a Super Bowl. So which of these 3 things? I made 3 different predictive models. Which of them is best? I found the following shocking. I expected one of them to be kind of a dominant favorite. They were almost split 1/3, 1/3, 1/3. The stats machine was just about tied for first. The How Good Raw score was technically best, and then the percentile one was a little bit behind. But they really do all keep pace with each other. I was absolutely startled that none of them are particularly better than the others. Okay, last thoughts on the matter. Stuff I learned. Gosh, I learned all about how to code in using Selenium to build a bot, basically. Fascinating. I took, this data mining idea of mine. I built an entire data mining machine from scratch. Like, it's a fully working engine. It was a fascinating project. I learned so much. One of the things I had so much fun with is I spent a lot of time going back and watching old historical football games. I'm reading all about these player names. Sabriel, there he is in the data cube, and you can just go find football footage of these old players. It was a lot of fun. Commercials in the 70s are so different. Very last thing about old stuff I learned. There's a man that nobody's heard of who is a god of football, and I wish more people knew about this dude. His name is Sammy Baugh. In the 40s, in the 1940s, this guy was absolutely king. He's one of the greatest players who's ever played. And he has statistics that to this day are shocking. In the year 1943, they call him Slingin' Sammy. Slingin' Sammy, Samuel Baugh. He had the NFL's most passing yards on the offensive side of the ball, most interceptions on the defensive side of the ball, and the most punting yards as their kicker, all in one season. He was the greatest at many different conflicting positions. Just incredible. I had so much fun learning about old football. And I think that's just about it from me. If you happen to have the time and you care to toy around with the app a little, it's fun. And I can't wait to look at the printouts that it has of current data, and like 3 years from now, I'm going to open up this little application again and see how accurate were the predictions. I'm so curious. All right. Thank you truly for the class. Thank you for this ridiculous final project, and I'm sorry if I carried on a little long. I loved every minute of working on this. It really made my semester. I had a lovely time. All right. Take care. Be well.